Today we are going to solve the Leetcode problem 2-sum. Given an array of integers and an integer target, return the indices of two numbers such that they add up to the target. So let us try to look at the example 1. So 2, 7, 11, 15 are the elements of nums, and if you see 2 and 7 add up to target 9. So the index value of 2 is 0 and the index value of 7 is 1. So the output should return 0, 1. So looking at example 2, the element values are 3, 2 and 4 and the target value is 6. So when you add 2 and 4, the sum will be 6. So the index value of 2, which is 1, the index value of 4, which is 2, should be returned as output. So they have given us two conditions. First condition is we should not use the same element twice. Although 3 plus 3 is also equal to 6, we cannot use the same element twice. So that is the reason we cannot consider 3, but rather 2 and 4. Similarly, if you look at example 3, the two values in the list are 3, 3. So you are taking the first value and the second value, and then 0 and 1 are the indexes. We should not return the elements, but the index value of the elements itself. Alright. So first let us try to write a pseudocode. Let us try to understand how the solution needs to be done. So let us take a value 2, 7, 11, 15. And as a human, how do we try to solve this problem is we compare each element of that list against every other element. So I take 2. In the first iteration, we check both the indexes are same, so we cannot consider this. And then 2 plus 7 equal to 9. So the condition satisfies. So we do not have to proceed further since it says that it's exactly one solution. Let's take another example. 3, 1, 2, 5, 7. And the target value is, let us say, 9. So we try to compare each element of the list with every other element. So you take 3. 3 plus 1 is 4. No. 3 plus 2 is 5. No. 3 plus 5 is 8. 3 plus 7 is 10. Similarly, you compare with 1. 1 plus 3. 1 plus 1. 1 plus 2. 1 plus 5. 1 plus 7. And 2. 2 plus 3. 2 plus 1. 2 plus 2. 2 plus 5. 2 plus 7. So here 2 plus 7 equals 9. So the index value of 2 is 2 and the index value of 7 is 4. So the result will be 2, 4. So the first condition is it will always have exactly one solution. So there will always be a solution and we should not use the same element twice. So I cannot add 3 plus 3, 1 plus 1, 2 plus 2. I can only add 3 with every other element and 1 with every other element except 1 and so on. So let us try to write the pseudocode first. So what we are doing here is we are iterating the same list twice. So loop 1 and then loop 2 and then we are checking two conditions. The first condition is if index of the first loop should not be equal to the index of the second loop. So we should not take the same index value of the first loop with the second loop. And if element of the first loop plus element of the second loop is equal to our target value, then our solution is done. So we return the indexes of I and j. So that's how we need to try to come up with the solution. So this is solution and this is called brute force mechanic. Since we are iterating it twice, so for the time complexity, it is big O and square. So first let us try to use the brute force solution where the complexity is big O and square, since we are doing two loops, one loop inside the other. Our loop 1, for I, for the first index, element 1 in enumerate. The reason we are using enumerate is because I want both the index and also the element of that list. of nums. The second loop for j comma or the second element iterator in our list against the same list nums. So our conditions were, if the index values are not equal, if not I not equal to j, that's our first condition. And our second condition is element 1 plus element 2. The sum of element 1 and element 2 is the value of target. Then we need to return both the indices, return I comma j. So when we execute this solution, you can see it has solved all the three cases. But as I said, the time complexity for this is big O n square. So let us try to bring down the time complexity. Instead of having two loops, let us try to understand how we could be able to get this in just one iteration, and we can use hash table for this. So let us try to understand that solution. All right. Let's take a list for example. 2, 1, 3, 5, 9, and let's say the target is equal to 8. Okay, so this is my list containing the elements 2, 1, 3, 5, and 9. So what we were doing in the brute force mechanism is we are trying to find those two elements which sum is equal to the target, and for that we have to do two iterations where it's causing the time complexity of big O n square. So we will try to bring that down the number of iterations by 1, where we'll try to get the time complexity as big O n in this scenario. So to do that, instead of trying to find both the elements which will sum up to the target value, we'll take the difference of the target and the first element and see if the difference is also part of the list. So if you take in this scenario, for example, the solution is 3, 5. The indexes of 3, 5 are 2, 3, right? So 3 plus 5 is equal to 8. So 8 minus 5 is equal to 3, which is present in the list. 8 minus 3 is equal to 5, which is also present in the list. So if I subtract the target with the element, the result, the difference result will also be part of that list, right? So the way we are going to take this here is, let us take the first element. 8 minus 2 is equal to 6. Is my difference 6 part of that list? No. So then I move on to the next element. So I have to store these values in a hash table. I want to have some kind of memory so that I don't have to keep using the second iteration or the second loop. So let us create a hash table. In Python, it's equivalent as dictionary, where the key value pairs the dictionary contains, and the key is my element value, and the value is index of that element, right? So I'll take the first element, 2. 8 minus 2 is 6. The 6 is not present in the hash table. So we will create a memory and we'll keep checking that memory. If it is there, then our solution is achieved. If not, we will keep adding the elements to the hash table, and then we'll keep looking back to see if there is a difference or not. All right. So 8 minus 2 is 6. 6 is not part of the hash table. So I take this 2 and my index is stored in 0. I move on to the next. 8 minus 1 is equal to 7. Is my 7 present in hash table? No. So my element is 1. The index is 1. Next is 3. 8 minus 3 is equal to 5. Is my 5 present in hash table? No. So the element value is 3 and the index value is 2. Next is 8 minus 5 is equal to 3. Is my 3 present in hash table? Yes. Right? So that means I was able to achieve to that place where my difference is present in the hash table. So the indexes are the index of the element 5 and the index of the element 3, which is 2. So 2, 3 is my output. Let us try to write the pseudocode for this. Let us create an empty dictionary in Python first. And then let us iterate the elements in the nums array for index comma value in enumerator of nums. Now, first get the difference. Difference is equal to target minus my element value. Then we need to check if the difference is present in the dictionary or not. So if difference is in my dictionary, then we return the indexes of I and also the index present in the match found. If not, what we need, we'll write it this later. If it is not found, then we need to add that element to the dictionary and move on to the next element. So adding that element h underscore map of key, the key is the element, is equal to the value is the index, right? So it keeps iterating each element. If it finds a difference, it will result and return back. If not, it will add that into the dictionary and move on to the next element. So the moment a match is found, what are we going to return? Our current index I and also the index present in the dictionary, which is nothing but h underscore map of element. Alright, so let us try to see how this works. So same 2, 1, 3, 5, 9 and say our target is equal to 8. So we create an empty dictionary and the first element value is 2. The difference is 8 minus 2 is 6. Is 6 part of the empty dictionary? No. So we add that 2 into the dictionary and we give that value as 0, which is index, and move on to 1. Similarly, the dictionary gets populated with element 1 and then index with 1. Again, element with 3 and then index with 2. It only goes to the if condition in the next iteration, which is 5. So the difference is 8 minus 5. So it goes inside the if condition then. So return the index of the current index, the index of the 5, comma, the index of the 3, which is the dictionary of that key, will give the index value. So let us first create an empty dictionary. And then, okay, so let's iterate for index comma element in enumerate of nums. So our difference will be target minus element. And then we need to check if the difference is already present in the hash table. If not, we will add it and move on to the next element. So if the difference is in the hash table, then we return both the indices. The first index will be our current index. The second index will be the index that is found in the dictionary. So to get that index value, we need to pass the value as the key into the dictionary. Else, we add that particular element into the dictionary with the index and move to the next element. So let us try executing this. As you can see, the time complexity here is big O n, since we are doing only one iteration.